Hello and welcome to another Solana tutorial. Today we're gonna have a look at how we can automatically create the codecs for our programs. Today we're gonna have a look at Kodama. And of course I have no idea how it works, but well, that's why I'm making those videos, to learn with you. Because for me, it's a waste of effort to learn it and then make a video about it. Then the video about it will be boring as hell. Hey, yeah, go to Codama and write this and then you're done. Boring. I want to have the full story of, I have no idea what Kodama is, to this is how we use it. So join me on this journey of learning about Kodama. That's where we left off at the last video about Gil. We found that we can generate the program client from an IDL using Kodama. So what is this? Wasn't this called Kinobi? Right, I heard about Kinobi, and yeah, that's right, there was a tool that allows you something IDLs auto-generate code, and I was like, at one point I want to have a look at that. I never did. And now it's called Kodama. Okay, why? Metaplex Foundation applied for Kinobi trademark. Metaplex. So there still is a Kinobi. It's a Metaplex thing. Generating UMI clients. You know, I've never been a big fan of UMI, but I am a big fan of the Solana kit and the new Web3.js and Gil. Thus, Kodama it is. Code and Kodama, tree spirits. Fits the node structure of the project. See, those are what I kind of expect that people go through when they name a project. Gil? Well, I like the fish icon. And it was available. No, I mean, nothing against Gil, but like Kodama, at least they thought about why. Okay, good. So far to the name. Now to the actual tool. It's a tool that describes any Solana program in a powerful standardized format known as the Kodama IDL. So seems like a different kind of IDL than what we used from Anchor, or maybe the same, or maybe a superset. This IDL can then be used to create a variety of utilities, such as rendering client code for programs in various languages, generating CLIs, and providing more information for explorers. Yeah, that's cool. So the more information for explorers is especially useful, such that the explorer can then say, hey, this input was that, and so on. If every program had such an IDL, then the explorers could be, way more verbose than just showing the raw data. So that's cool. And also the rendering client code, I think what that is, I don't know why it's called rendering. Is render a word for auto-generate? It's a process of converting code into viewable. No, is it that? I mean, yeah, that's what I understand it, right? You render a UI element. Rendering client code? Generating CLIs is also cool. I think what they're trying to say is, or what I hope that this means, is that we can create code, like auto-generate code, that we can then use in our frameworks like Gil or the Solana kit. Because that's my goal for this video. And I'm hoping that I can do this with Kodama. Yeah, so Anchor programs, shank macros, coming soon. For now, we can render client code. Great. Okay, so how does this idea look like? It's designed as a tree of nodes, starting with a root node, which contains a program node and additional data such as Kodama version used when the IDL was created, because also the IDL structure might change. That's why they have a version, I guess. Kodama provides over 60 different types of nodes that help describe just about any aspect of your Solana program. Kodama nodes. Account node, define type node, error node, instruction account, instruction argument, instruction byte delta, PDA, program node. This might become relevant later when we actually have a look at it. For now, let's just understand that an IDL has this root, then a program, and then it can have a bunch of stuff. Like a program has accounts and instructions, and then the account might have a struct type, then each instruction might have instruction accounts. From program to Kodama. Okay, there are various ways to extract information from your Solana program in order to obtain a Kodama IDL. Kodama macros. Not yet available. Oh, great. From Anchor, if we're using Anchor programs, we get an Anchor IDL, and we can then, from the Anchor IDL, build such a Kodama IDL. Note that the Anchor IDL might not offer all the information that Kodama can hold, and therefore, you may want to transform your Kodama IDL to provide additional information. Or we do it by hand by manually writing a Kodama IDL. We may provide tools. Coming soon. And once we have that, we can use visitors to transform it. And last point, from Kodama to utility. What can we actually do with it then? Now that we have the perfect Kodama IDL, you can benefit from all the visitors and tools that provide utility, such as rendering client code or registering your IDL on chain, so some explorers can dynamically display relevant information for your program. That's actually super cool. I mean, just for that, I would want to build that for my programs. Not that... How often have I read that some features are not available yet? Feel free to reach out if you want to contribute. Well, I want to first just use what we have and then see if I like it. And then still not contribute because I'm not a coder, I'm a video maker. Rendering client code. So what is that actually? What do you mean by that? Want people to start interacting with your Solana program? You can use special visitors to go through your Kodama IDL and generate client code. There we go. Generate client code. That's what it is. That you can then publish to your end users. Currently, we have the following renderers available. Renderer.js renders a JavaScript client compatible with the Solana kit. Yes, that's exactly what I need. That's exactly what I need and want. I don't care about Umi, no. Rust, also helpful. I have used that before. That's cool. That's cool. That's cool. Maybe we also want to try this, but mainly I want to try this. And of course, more to come. Of course, eventually. Here's an example of how to generate JavaScript and Rust client code for your program. Wow, that's complicated code. Holy shit. 2 lines. We import it from the renderers and then we call render. Wow. That's so cool. I want that. I want to try that. There might be a standardized way how we can then publish this IDL. But since this is a coming soon topic, we'll also ignore it for now and try to get to this part. I basically, for a, let's start easy, Anchor program, I want to do this. Because Anchor will make it easy and provide an IDL for me. Solana sea-level framework. That's why Anchor. Because of sea level. That makes sense. Because the Solana runtime is called sea level. And Anchor has an IDL specification. Now it makes sense that Solana tooling is ocean themed. So let's do something that we haven't done in a while. Write an Anchor program. I don't even have Anchor. I don't even have Anchor installed on this computer. Well, time to get it then. Perfect. So, Anchor, init, glib. Before I brick my operating system, I'm just gonna downgrade Anchor. Let's try 0.30. Okay, there we go. Now using Anchor version, perfect. So Anchor, cool. Does this guy allow me to do that? Yes. Okay, good. Not the nicest way to deal with this. I would like to use Anchor in version 31, but before I brick my Ubuntu, just gonna use an older version. This is an Anchor program. And again, I'm late. Why is my Windows so slow lately? I haven't written Anchor programs in a while. If I want instruction data, I put it here, right? I can have a number. And again, we're getting the same issue because it's just a demo. I don't have good names for it. And I want a string, and then I want something optional. What did I have last time? An optional pub key. Do you think that will work? What this initialize should do is basically write those fields into an account. Man, I haven't used Anchor in a while. Demo data account. And because I'm nice, I'm gonna put the optional pub key here. Actually, it doesn't matter because it's also variable length, but it still could make it a C option. The authority, I mean, I have a signer, but I'm gonna ignore it. Payer must be mutable. That's a good point. And space, well, really I should 8 for the discriminator, 8 for the number, 32 plus 4 is 36 for the C option at most. And for the string, well, the string's length. How did I get the arguments in here? I think I need to put the number here, but it doesn't matter how I call it. Length. Oh, plus 4. I think 4 is the string length. And then we initialize this account, and then we just need to write it. Why do you complain? Bosch serialize for C option is not satisfied. You cannot serialize a C option for a pub key. Could you do a pub key? Yes. Could you do an option for a pub key? Yes. Okay, well then do an option for a pub key, fine. Okay, and basically, how did it go? Context, you have accounts, data account, number is my number. Do this for all three. Optional key is my optional key. String is my string. And anchor takes care of, you know, persisting this. I don't even need to do anything. And that, ladies and gentlemen, is my simple demo anchor program. It has an account and it has input data, and I'm gonna attempt to build this. Build. Oh, also with you, I don't know, this. Let's pretend this is a version 3. Yeah. I mean, it's nice and easy to develop with Anchor, but the dependencies are just crazy. Okay, meanwhile, Coda, ignore case, in case my computer wasn't overwhelmed yet. Coda, this is gonna be my keeper, and then, should we do another one for the program, or are we happy with this? Anchor program, AncP, my program ID. Oh, it's still not done building? Wow, 6 minutes, holy shit. Oh, whoa, holy, what is going on now? You're doing the same thing again? Why? What? Error building IDL failed. Building IDL failed. May come from an old version of Anchor derive accounts. See, that's another reason why I don't like Anchor. It's just confusing with those macros. They're supposed to make everything easy, but as soon as we have some conflicts with stuff, difficult. We did not manage to get an IDL. Holy... Okay, what am I doing wrong? It's a simple program. What the am I doing wrong? It's already installed. Well, then use it. Version and current version don't match. This can lead to unwanted behavior. Well, but at least this works now. Hehe. I hate versions. Ignoring a warning. And did we get our IDL? We did get our IDL. Finally, after an hour or so, we have an IDL. See, that's what this Anchor IDL has. It has the address, some metadata created with Anchor. The instruction, there's one instruction with this discriminator, and it takes 3 accounts and it takes 3 arguments. Option pub key, I like it. And then it has an account with this account discriminator, the demo account, and the struct for the fields of that account, again here with an optional pub key and the string. Nice. That's all the IDL gives us. I mean, could have created this ourselves as well, but no, want to get it directly from the Anchor program. And now finally to the interesting part where we use Kodama to get a Kodama IDL. This is what we want to do. npm install Kodama, create Kodama IDL, and then we just run this. Let's print it first. Nodes from Anchor, you don't have that. Well, maybe that's a separate package. So npm add this, cool. And then my Anchor IDL, well, this I will load from Anchor demo target IDL, just a local path. Anchor demo JSON. Didn't I just install this? Why do you not find this? This is working great. It's not Kodama that's frustrating me. There we go. It's looking better now. Okay, tell me again what you need. An Anchor IDL. Wait, didn't you export the types as well? Types. Maybe you need it from types. Ah, there we go. Again, this is the same thing except it's exporting my IDL in a TypeScript type instead of just, you know, the IDL, but it's literally the same. Only refers to a type but is being used as a value here. Okay, no, you did want to have the Anchor IDL. Hold on. You did want to have the IDL. Yeah. And then you complain that not assignable. Shit, wait, what do you need now? Yeah, this is you take the JSON. That's what I did. Somehow you're still not happy with the types. It's not assignable to Anchor IDL. Well, according to you, what is an Anchor IDL? An IDL v0 or an IDL v1? Address, that's what I have. So address metadata instructions. Address metadata instructions. I have that. Metadata needs to have name spec version. Name spec version. Also have that. I mean that it seems to have that type, Type string is not assignable to IDL v1 type. Do I have an issue because I called my string string? Maybe it has an issue with that. Fine. Kids, don't call your string string. Call them text. There you go. Text, text. Build again. Now my IDL has text, but it doesn't have, this is not up to date. Or maybe it's really, there's really a, hold on. You know what? I'm gonna ignore this for now. I'm gonna try to run it anyway. I mean, seems to work. At least it's not crashing. I don't know what this thing is. It's a Kodama. Accept clone, get JSON, get root, update. Okay. How about get JSON? There. That looks like a JSON. Root node, then program node, anchor program namer with that public key. So that IDL looks a bit different. Let's save it. Is that even JSON format? I think so. And the data will be this. Then we should get Kodama IDL. We can format here and voila, that's what this looks like. But the root node, program, which is a program node, and then accounts, which is account nodes with all the fields, discriminator, offset 0, name, discriminator, kind. But the actual value for the discriminator I lost, no? And then instructions, name initialize, true, true, not optional. Authority also true, true, and not optional. The system program is not writable, not signer, but also not optional. Cool. So that it got. The arguments, discriminator, size is 8 bytes. And then we have the default value. Well, is it a default value? It's, yeah, kind of the default value, but also it's kind of the forced value. This is the base 16 encoded, so that's hex encoding 8 bytes. Yeah, okay. So this discriminator, it got as a default value. For me, it's not a default because it's the forced, you need to have this, otherwise this instruction is not being called, but yeah, whatever. And then we have the number with the types, and there we don't have any defaults. Yeah, that's fine. And then the optional key, option type, and then item with a public key. So it's trees, it's always trees. The kind, here we have the instruction argument, then we have the, it's just not so easy to read because this instruction argument represents this entire thing. This option type represents this thing. And this public key type represents this thing. That's a bit counterintuitive, but yeah, it's there. The kind is always in there. Same as in here, the kind, the root, you know, that's the root has this kind. And then there's the program, which has kind program node. Because, you know, in my mind, it would be like program node, this. But no, this is already the name for it, and it's of kind program node. Yeah, whatever. But I guess that makes sense. I represent all of my instruction arguments. The one thing that I feel like we lost though was the account discriminator, because in my IDL I had the account discriminator. Oh no, here. Yeah, it's also, okay, so it's also in hex encoding in there. Okay, fine. Also as the default value. Fine. Okay, so I think we don't need to, you know, add anything. I do find that IDL much more compact, the Anchor IDL. It's much easier to read for me. Also maybe because I'm used to it. However, with the Kodama IDL, you can probably do more because of that fixed tree-like layout. Probably easier to work with this from a coding perspective, but it's less easy to read. Whatever, we don't need to read the IDL, we can just work with it. How can we work with it now? Because ultimately what I want is be able to easily call my program without having to write all the codecs and stuff myself. I can then update. Let's try this as well. Let's see what that does. Kodama update. I read that Kodama, like I created this Kodama and then I update with a visitor, and I'm using an update accounts visitor. Well, what do you take? A map. Let's do something simple first. Update programs visitor. I just want to figure out how that is supposed to be called, because that, honestly, that example is really bad, because what you put it in there? Give me a concrete example, please. Because what's this map? A map of record string program updates and a record p-in-k-t. Okay, so an empty map would work, but here I can put in update 1 or whatever, and then a program update. This is not a program update. Number is not assignable to program update. Okay, so I'm understanding that type. Good. Needs to be a program update. How do I get a program update? Ooh, I can have a delete true. So my update 1 updates the name. Let's see if that would work. Let's see if I updated the name. Program name. No. Still anchor demo. Maybe the string represents something. What would it represent? Yeah, okay, so I shouldn't call this update. What would I call it? Probably this one I would call program. If I call this the demo account and this the program, would that work? Wait, hold on, but it kinda... Wait, but that worked. The second one worked. Maybe. Let's do the same for update instructions visitor and update my initialize. Delete that. There we go. So the deleting works. I know how to delete nodes. Great. Still have the program. Hold on, but can I also delete the program by doing delete true? Nope. Oh yeah, I'm going by the name, not by that thing, because that's always called program. I'm also here not going for arguments, but for discriminator. And with the instructions, I'm not going for instructions, but for initialize. So obviously for the program, I need to go for the name, which is anchor demo. So like this, and then I can also delete this. Yeah, no. Or yes, but I can then not delete the other stuff anymore. Expected node of kind root node got null. Okay, whatever. But then name, can try and set this to updated name. There we go. Now that works. That's how you can change stuff inside the IDL as well. I mean, or you manually go there and, you know, change stuff here. That would also work. But that's how you would do it programmatically. Here, that's how you would delete it. That's how you would change individual elements of it. But not so important, all of that. Let's save the original again. And finally, because that's just playing around with it, I don't think we need to visit them or change anything in the IDL. I want to finally get to the rendering of code. I want to generate myself some code for the Solana kit. So this is what I will need. pnpmi add the Kodama renderers.js. Do we have example code? Yes. Let's go ahead and generate code. So from renderers, I'm gonna get from renderers has all of them. Yeah, why not? Let's get renderers. Not just the JS one. Renderers probably has all of them. And then I have the Rust and the JavaScript. And I'm gonna do the same thing as here. Either I once again create from root node from anchor, or since I now have the Kodama IDL, create from root with root. How would I load it from an IDL? Does this thing actually have examples or some stuff? Get root node from IDL. And that comes from utils. So you put it in directly. This is a root node, the Kodama IDL, apparently, from what I read in this source code. If we have an object, if it's not null, and its type, it has a kind root node and standard Kodama. Let's check the Kodama IDL. Standard Kodama and type root node. Yeah, so it is a root node. It's a bit complicated, honestly, and the docs of this whole thing are not particularly great, but that would mean that I can just import Kodama IDL from Kodama IDL, or I would again read it from the anchor or whatever. But now we have this Kodama IDL, so I want to use this, and then I create from root with this thing. Type string is not assignable to root node. You know what? This is gonna work. I trust that it's gonna work. I don't trust my type checker that this actually doesn't work. So, and then I can render that stuff. So what goes here actually? First, let's just do JavaScript stuff. Well, no, first let's see if I can get to the Kodama. Let's see if we would get that far. Yes, there you go. So this works. it just, my type checker just doesn't like it for some reason. And that's okay. I don't trust my type checker anymore. Now we can do this. Let's do a generated. I just do one folder generated TS options. Cool. How about no options? Let's see what happens if we do this. Oh, it just works. Let's see. We have a generated TS. Wonderful. And cool. Here we have accounts, instructions, programs, shared. This is auto-generated. Program. Oh, it imports the Solana kit. Anchor demo program address. S address. Anchor. Nice. Nice. And then fixed encoder. Encode this contains bytes. Nice. So it checks the account discriminator. Identify instruction. Maybe because we just have one, we just check for this one. That's the program. Then the accounts. That's the discriminator. Nice. And here it looks really nice again as bytes, not as a weird hex. But yeah, for a text file, actually hex is probably better. It's more compact. Nice. And there we see the whole thing with the discriminator, number, optional key, text, and all those encoders. See, that's how it's auto-generated. In my encoders demo, we did that manually. You can watch that here. We wrote that manually, but you can just auto-generate that with Kodama once you have that IDL. Oh, that's so cool. So we have the encoder, the decoder, the codec that combines both of them. Nice. Nice. And then we can fetch demo account, fetch encoded accounts with the RPC. So it takes an RPC. Cool. And then also the instructions, probably same thing. Oh, if we had more instructions, it would probably have them in separate files, and we just have one, the initialize, and that's here. Initialize instruction. Oh, so many types. Initialize instruction data is discriminator, number, text, and optional key. Then again, we have an encoder for this, and the decoder, and the codec with both of those. That's so nice. Just auto-generated code with address type of anchor. Demo program address. That's cool. I like this. Even with the account matters. So that's get initialize instruction. Nice. With the input, you can do a program address. And if you don't do that, then you give the anchor. Oh, this is cool. All right. So let's use this. The data is get initialize instruction data encoder. Encode the argument as data, and that's the input, and the input is from here. That's so cool. I like this. This is so nicely typed from the IDL. Let's actually try and call that program with the code that we just generated. But actually, before we can call the program, maybe we should... Can I get an airdrop? Nope. What? Rate limit exceeded? Why? Maximum of 2 every 8 hours. I haven't requested one in forever. How am I gonna get definite sol then? The most difficult part is waiting for things to compile and getting definite sol. Kodama is easy. Yeah, found some. Sending. There we go. Manually airdrop myself 2 sol from a different wallet. Okay, but now I can Solana program deploy the anchor demo target deploy anchor demo SO. 200 transactions. Yeah. It's an anchor program. It's a bit bigger. There we go, but it works. Anchor program deployed. Wonderful. And it cost me, 1.5 sol for an anchor program. 1.4 something. Crazy. Anyhow, now we can go and create ourselves call program. And you know what? I'm gonna do it with GIL. So basically, I borrow the same code as I had in the GIL example. We load a key pair. Create the RPC and this function, create a transaction and send it. So the only thing that I'm interested in right now is how to create this instruction. So our initialize instruction to our program. And this I'm gonna import from generated TS. We're interested in instructions. Here I wanna have the get initialize instruction. There we go. Wonderful. So we get an initialize instruction. This is looks very much like what I would do in general with the, oh, this is so nice, with a kit. And then I just provide those things and that's it. Wow. Okay. That's easy. So authority, it's just a guy paying. That's my signer. Now the question is, do you take the address or actual signer? Key pair signer. And you want a transaction signer. Yeah, you need an actual transaction signer. Okay, not just the address. Then the system program, if I don't provide it, I guess it will take the system program per default. The data account, well, this is gonna be interesting because it's gonna create a data account. You know what? Data account, generate key pair signer. Oh, and await this. It should be fine because the data account can be any account, I guess. And then we just need the number. Well, guess what we're gonna take here? 43, because I mistyped. Text. Yo, this is done via Kodama. Optional key. You know, it's optional. Option or nullable. Well, null. No key. Just to prove we have an actual option. And that's the instruction, and that I put in there. Do you think that would just work? I'm skeptical, but also, why not? Call the program. Oh, it doesn't work. 5 errors. Top level await. Ah, always the top level awaits. Once again, we do an async function that does all of that stuff, and then we call that here. Now, module not found. Cannot find Solana kit. Who needs that? Oh yeah, the generated imports the Solana kit. Yeah, that makes sense. So, I mean, now I have it twice. I have it once in GIL and once the kit. I hope this will not cause problems. But well, let's import Solana kit and run it again. Yeah, nice. Transaction confirmed. And we can check it. Wow, that was so easy. My coda created this account. We're gonna copy that. And AF. Yeah, that's the instruction discriminator. Fun. And I wish I could tell the Explorer, hey, here's my Kodama IDL. Can you parse this better? But this is coming eventually kind of a situation. Or coming potentially. We don't know. But yeah, we could call the initialize instruction. See, that's how easy it is. Literally, this thing, like, it doesn't get any easier than that. Just providing the things and that will build the instruction. That's idiot safe. Like, pretty cool. Pretty freaking cool. It even put in the system program. I didn't even have to do that. Freaking smart. Okay, so that's the call the program. Let's do a check account. What we want to do now is from the accounts, I'm gonna get the whole codec because it's so fun. From the program, I'm gonna get the identify. Here would also have the program address. So the data account we said was this one. And then from the RPC, let's get account info for this account. A value data. And that we should probably somehow be able to encode into a data account, right? So no, the other way around. Decode bytes. So that's what I'm gonna put in there, the data. Oh, this is base 58 encoded bytes. Base 58 codec. It's always the other way around. It's decode, encode. Yeah, that exists. And then the bytes I put in here, and then I get a data. And that thing should have the discriminator number and optional key. So let's just log this and run this. Check the account. Boom! Look, the number is 43, the optional key, none, and the text, yo, this is done via Kodama. Again, super easy. I just get the account codec and decode the bytes. First, I need to encode those from base 58 to bytes, because the RPC response gives me the base 58. I could also tell it to give me base 64 or something, but you know, whatever. But yeah, then I just, from that data to those fields. And the discriminator I could ignore, but actually, before we ignore the discriminator, there is this identify anchor demo account. Wait, what does that do exactly? Provided account could not be identified as an, and otherwise we return. So this you would already do on the bytes, I guess. And it gives me the type, otherwise it throws an error. If it's not of that type, then it throws an error anyway, so it wouldn't even get there. But I guess it identifies it as this, and it identifies it as 0, well, because it's an enum, right? This stuff is an enum, and the demo data account, I should, you know, match those. But yeah, it identifies as this because it has this discriminator. Nice, nice. That's pretty nice, having those generated things. Anything else that we want to try? I mean, we have accounts, we have instructions, we have the program ID and stuff. Yeah, what else do you need? Errors, we could also probably get errors, but I don't have any in my program. So yeah, that's cool. Kodama is pretty cool, actually. I like it. And just because I'm curious, let's also generate the Rust stuff. No options, generated rs, generate code. Then we also have the Rust stuff as accounts, instructions, and it looks pretty similar. The initialize instruction, new, it's the discriminator. It's a bit harder to read because it's Rust. But yeah, we have the types, instruction with those accounts, those arguments, and then remaining accounts if there are some. Data account, authority, system program. Yeah, so I'm assuming that it would work, you know, similar to what we saw in TypeScript, that there are functions that allow me to build those. Where would those be? We get the instruction. And then same for accounts, a demo account, the try from with a deserialize. And we can fetch all demo data accounts with an RPC. We'll get multiple accounts for those addresses and decode all of them from bytes. Do we also have that in TypeScript? Yeah, it has a fetch. So maybe it is even simpler than what I did. Fetch all, fetch maybe, fetch all maybe. The difference is the one will error, I think. Yeah, because it asserts that it exists. Okay, let's fetch my check account. Let's not just get the codec. Let's fetch the demo account. Instead of doing all of this manually, I just say fetch demo data account. This is my RPC. And this is my account. Let's see if I get the same thing. Check account. Oops, I need to await something. And there we go. We indeed get the same thing, even with more stuff. So not just the data, but also the executable flag, the lamperts, the owner, the space, the address itself, and whether or not it exists. But yeah, that was the part that I was interested in, the data part. So yeah, even easier than what I had before, where I just got the data and checked that it's that account and got the codec. That's all hidden in the fetch, so I don't even need to bother with this. I can just fetch, put in the RPC, put in the account, and bam, I have the demo data. It's not just the data, it's the entire account, but this one has the data, and here we have our fields. So this would be the demo account, demo data, is demo account data. Then it would be the same again. Boom, nice. And of course I can also put in different values and a public key here. So optional nullable of address. So actually let's do such that we also used it once. The program address, there, take the program address, call the program. Sweet. See that we have created this account, and then check this account, and voila, we also have some option, our program ID, and this was again done with Kodama. Isn't that cool? I mean, I really enjoy this. I really just enjoy the auto-generated code here. I mean, it also looks good color-wise. I like it. I don't know. Yeah. Okay. So I'm gonna end here. Thanks for watching. This was an intro to Kodama, how you can use it, what it can do. I actually enjoy this because it makes development pretty simple. You can easily create instructions and fetch accounts. Pretty nice, just based on the IDL from Anchor. You can also create your own Kodama IDL, and there might be different tools to create those for different programs, but today we just looked at it from an Anchor IDL. There are also other tools that create IDLs for programs that are not written in Anchor, but that's out of the scope of this video. I hope you learned something. I enjoyed this way more than I thought. So try out Kodama. Watch some other videos. Here's the one I made about Gil that got me to check this out in the first place. Then you can like this video, subscribe if you haven't already, and I will see you in the next one. Till then, auto-generate your code with Kodama. Okay, bye!